Bismillahirrahmanirrahim. Dear students, grade 11, chapter number 10. So, according to your reduced syllabus, so the starting from the concentration units. So, solutions are the homogeneous mixture of two or more than two substances. When the solute and solvent, just like sodium chloride is a solute and water is a solvent. So when one solute and one solvent, we call binary solution. So solution is a homogeneous mixture of two or more than two substances to have a uniform composition is called solution. So when we are talking about the concentration units, then there is one thing we usually use: dilute solution and concentrated solution. So when we are going to talking about the dilute solution, means the amount of solute is less smaller in a solution. The amount of solute is comparatively less in a solution is called a dilute solution. And concentrated solution means the amount of solute is larger in a solution. So this information is incomplete about the concentration of solutions, because we are not going to explain how much amount of solute is present in a solution. So this is not meaningful. So we need to define solution composition more precisely in order to perform calculations. This will not help us in the calculations. So the amount of solute, solvent and solution may be expressed in volume, in number of moles. So for the preparation of solutions, exactly amount and concentration, these two solutions will not help us. They are not going to explain precisely the concentration of solutions. That's why we want to see different methods how to calculate the concentration of solutions in form of volume or mass. So number one unit of concentration is units of concentration. Number one unit is mass to mass. Generally we write M over M or W over W. Percentage, mass, percentage of solutions. So these mass to mass percentage of solution, this is a solute in grams. Solute in grams and solvent also in grams, both. So when you are going to prepare mass to mass or W over W percentage of solutions, then how we define number of grams number of grams of solutes, number of grams of solutes dissolved in 100 grams of solution. Number of grams of solute. Number of grams of solute. 2 gram, 3 gram, 1 gram dissolved in 100 grams of total solution. Means suppose I am going to prepare 10% solution of glucose, W over W, percentage composition. So according to this definition, you have to dissolve 10 grams of glucose. 10 grams of glucose to prepare to make total mass of solution will be 100 grams. Total mass of solution will be 100 grams. Is called W over W or M over M percentage solutions. So how we are going to calculate percentage? There the formula: mass of solute divided by mass of solution multiplied by 100. Mass of solute 10 grams, mass of solution 100 grams multiplied by 100, you will get the percentage composition of the W over W solution. Suppose the example is given here. Calculate the mass percentage solution containing 10 grams sugar in 100 grams of water. 10 grams sugar or 10 grams glucose in 100 grams of water. But definition is a number of gram of solute, okay, 10 grams, these 10 grams, 10%, 10 grams, dissolved in 100 grams of solution. Water is a solvent, not a solution. So that is why when you are going to apply this formula, mass of solute, okay, 110 grams, this is 10 grams, divided by mass of solution, means total of mass of solution. Here you are taking 100 grams of water means solvent. The mass of solute is 10. So you have to add both. 110 grams of solution, 10 grams of solute and 100 grams of solvent to make 110 grams of solution. So multiply by 100 to make a percentage of solutions. You will get 9.09. So this is the M over M or W over W percentage of solutions. Now number 2 is mass volume percentage. Mass volume. Like this means solute in grams and volume means centimeter cube. dissolved in 100 centimeter cube of solution. You should have the total volume of solution 100 centimeter cube. Total volume of solution. Number of grams of solute dissolved in 100 centimeter cube of solution is called mass volume percentage. So by using a mass volume or W volume percentage, suppose you are going to prepare a 5% urea, 5% urea by W over V solution, then 5 grams of solute divided by volume of the solution. Volume of solution, suppose 100 multiplied by 100. You will get the mass volume. To take 5 grams. Actually, we are going to prepare these solutions in the laboratory. We have volumetric flask, different volumes. Here is a mark. So written here, different. You will find in the laboratory different sizes of the volumetric flasks. Maybe 10 centimeter cube, maybe 50 centimeter cube. So because we are calculating here percentage, so that's why we have here 100 centimeter cube flask. Means from this level to this level, it has to occupy 100 centimeter cube. So by using a balance, when balance, electronic balance, electrical balance, take a 5 grams of urea, 5 grams of urea here in a beaker and dissolve in water, some water put. Suppose you are putting 10 milliliters, 50 milliliters, 20 milliliters of water by glass rod. You have to dissolve it. It is easy to stir because the area of the beaker is going to be large. So by using glass rod, it can be dissolved very well. Then by using a funnel, this is a funnel. So by using funnel, you have to put this in a flask and make up the volume up to this level. Should not increase. The level should not be increased. So this is called a 5% solution W over V. Number third is volume to mass. Volume to mass, inverse of this. So here you have to take a volume in centimeter cube of the solute and mass in grams of the solvent. To make a 100 number of centimeter cube, volume in centimeter cube of solute dissolved in 100 grams of solution. Total mass of solution must be 100. So if you are going to calculate the 5% solution of ethanol, 5% solution of ethanol by using volume to mass, 5% solution of ethanol volume to mass, then you have to take a 5 centimeter cube of the solute. So, dear students, you have in the laboratory graduated cylinders, different sizes again. Graduated cylinder, different size, and this is a calibrated here. Take a small size. So 10, maybe you can take 50 milliliters or 20 milliliters of this one. So here the 5. So you have to measure the alcohol up to 5 here, this line, and then you have to transfer in the beaker here. It is pre-weighed, should be weighed first. There are 5 milliliters of ethanol here, and then you have to weigh first this one, then put on the balance, then weight of the beaker plus total weight of the solute and solvent to make 100. Suppose initially you took the weight of beaker is suppose 100 grams. This is the weight of beaker only, empty beaker. Then you have to transfer 5 milliliters of alcohol here, and then on the balance you have to put and add more water. So till your answer 200 grams. Till your answer 200 grams. 200 minus 100, you will get 100 grams of solution. So this is the volume, mass, volume by weight, volume of mass solution, volume of the solution in centimeter cube divided by mass of solution in grams. Volume of solute dissolved per 100 grams of solution is called mass percentage. Total volume of the solution will be not known, and it must be equal to 100 grams of solution. The last one is number 4. Volume to volume. Solute and solvent both in centimeter cube percentage in 100. So number of centimeter cube milliliters, volume of solute 5 milliliters, 10 milliliters, whatever you want to make the percentage, dissolved to make 100 centimeter cube of solution. So this is very simple. If you are going to prepare a 5% solution of ethanol by volume to volume, so by using the graduated cylinder, this is a graduated cylinder, I measure the 5 milliliters of ethanol by using this funnel, transfer in the flask and put the more water, make up volume here is called a 5% solution of volume to volume, because we know this flask has the ability to accommodate only 100 centimeter cube because written here. It is standard. So 5 milliliters you can get from here, from the graduated cylinder, and then you have to make up the volume up to here. So dear students, these are the percentage of solutions. Chapter number 10. Chapter number 10, solutions, concentration units, percentage. We done all. Now there is another one. Number 5, molarity. Molarity of solution. Molarity of solution means molarity is denoted by a capital M. So molarity means number of moles of solute, number of moles of solute dissolve one volume of solution in 1 decimeter cube. So you should have the volume of solution 1 decimeter cube or 1000 centimeter cube. So number of moles of solute dissolved in 1 decimeter cube or 1000 centimeter cube of solution is called molarity. Now moles, number of moles you calculated before, mass in grams of solute divided by its molar mass. So instead of number of moles, I am going to write the again formula. Instead of number of moles, I write mass in grams of solute, mass in grams of solute divided by molar mass, volume of solution in decimeter cube. Volume of solution in decimeter cube. So this is the molarity. Mass in grams of solute divided by molar mass multiplied by 1 over volume of solutions in decimeter cube. So there is one example, very simple. 0.25 grams of sodium hydrogen carbonate. Put 0.25 grams here. Sodium carbonate, calculate its molar mass, put here. In 100 centimeter cube of solution, so divided by 1000, make it decimeter cube, then you will be able to calculate 0.0298 molar solution. This is the molarity. Then there is another concentration unit. called molality of solution, small m. Molality of solution, small m. So, molality is defined as number of moles of solute, number of moles of solute dissolved in 1 kilogram of solvent, not solution. Number of moles of solute divided by dissolved in 1 kilogram of solvent, not solution, is called molality. So molality is number of moles. I can write mass in grams of solute molar mass of the solute multiplied by 1 over mass of solvent in 1 kilogram. So this is the formula of molality. Example is given here. Take 1 gram of ethanol. 1 gram. Put 1 gram here. Ethanol. Molar mass of ethanol is 46. So 1 gram divided by 46. Mixed with 100 grams of water. So mass of solvent is 100 divided by 1000. Change into kilogram, then 1 over the mass of the solvent in kilogram. So you will be able to calculate the molality. Dear students, molality means mass of the solvent. Mass. Molarity, volume of solution. Volume of solution. So that's why here written molarity is independent of temperature, whereas molarity depends on temperature, because molarity is based upon volume of solution. Increasing or decreasing the volume changes, and molarity remains constant because of the mass. So as the temperature increases, the amount of solution remains constant, no change. But the volume of solution increases slightly by decreasing the molarity. So that's why molarity is independent of temperature, but molarity is dependent on temperature. So here the question is a self-check. So here is a 5% dextrose, means glucose C6H12, dextrose sugar 5%, and this is isotonic solution, 5% dextrose In the book it's not written, but you have to mention this will be a m over b. According to m over b, so calculate the molarity. So 5% means 5 grams of solute means glucose in 100 centimeter cube of solution. This is a statement. So molarity will be equal to 5 grams mass of solute. Molar mass of glucose is 180. Multiply by 1 over 100 means 0.1. You will get the answer. You will get the answer. Second one is 9% saline solution, sodium chloride. Sodium chloride, 9%. So same, 9 grams of the solute dissolved in 100 grams of solution. So molarity of this will be equal to 9 grams of the sodium chloride. Molar mass of sodium chloride is 58.5 and 1 over 0.1 because 100 centimeter cube of solution. This is a molarity you can calculate here. Mole fraction indicated by X. Mole fraction. Mole fraction is a ratio. It is a ratio of number of moles of solute divided by total number of moles present in a solution. Number of moles of solute present in total number of moles of solute and solvent. Suppose you have binary solution, number of moles of A solute and number of moles of B solvent to make a solution. This is a binary solution. So how I calculate the mole fraction? So mole fraction of A solute, number of moles of solute divided by number of moles of solute plus number of moles of solvent. This is the mole fraction of A. Similarly, mole fraction of B is number of moles of particular this solvent, number of moles of A plus number of moles of B. So you will get the mole fraction of the solvent. So remember that mole fraction of A plus mole fraction of B must be equal to 1. Mole fraction of the A plus mole fraction of the B must be equal to 1. After calculating, your answer must be 1. So here is a numerical. If you see in the mole fraction, aqua solution containing 100 ethanol per decimeter cube of solution has the density 0.984 calculate the mole fraction of component of the solutions. So first of all, students, see your book, calculate the mass of solution. So mass is equal to D into V, density is given, and volume is 1 decimeter cube change into centimeter cube, so it should be 1000. So 0.984 density multiplied by 1000, you will get 984 grams of solution. 984 grams of solution. So how we calculate the mass of solvent water? So mass of solution minus mass of solute. So you have the mass of solute ethanol 100 grams. So 984 minus 100, you will get 884 grams of water. So change into number of moles. So moles of the water 884 divided by smaller mass 18, 49.1 moles. Similarly, number of moles of ethanol 100 grams given 46 molar mass. So 100 over 46, you will get 2.17 moles. Now apply the same formula. Mole fraction is, if I am going to calculate mole fraction of water, 49.1 moles of water divided by total number of moles of the solute and solvent both. These are 51.27. You will get 0.958. Then mole fraction of ethanol. Number of moles of ethanol are 2.17 divided by total number of moles, means A plus B, ethanol plus water, 51.27. You will get 0.042. So dear students, if you add these two mole fractions of water and alcohol, you will get 1. The total mole fraction of the components present in the solution must be equal to 1. So this is the mole fraction. It is a ratio because of the ratio between solute and the whole number of mole of solvent. So it has no proper units. We don't write the units of mole fractions. So this is another one unit mole fraction. Then parts per million. Parts per million, ppm. Parts per million solution, ppm. Mass or volume of solute divided by mass or volume of solution multiplied by 10 raised to power 6. Mass, volume of the solute divided by mass or volume of solution multiplied by 10 raised to power 6 million is called parts per million ppm solution. So here is a numerical 10.6, and atmospheric chemist reports that 1 decimeter cube, this is the mass of solution, so change into centimeter cube should be 1000. So this 1000 centimeter cube is a mass of solution air. He took the 1 decimeter cube of air. In urban area, Karachi, like this one, Jeddah, contain 3.5 into 10 raised to power minus 4 centimeter cube of carbon monoxide. So this 1 decimeter cube, 1000 centimeter cube of the air contains this amount of carbon monoxide. How the air is polluted. So parts per million, I told you, volume of mass of solute, so volume is given here 3.5 into 10 raised to power minus 4 centimeter cube divided by volume or mass of solution. So this is 1000 10 raised power 3 centimeter cube multiplied by 10 raised power 6. You will get 0.35 parts per million pollution of carbon monoxide in 1 decimeter cube of air. This is the parts per million. Then there is a parts per billion. Parts per billion. Parts per billion. The volume or mass of the solute divided by volume of mass of the solution, 10 raised power multiplied by 10 raised power 9 billion is called parts per billion. Then there is a parts per trillion. Number of parts by weight or volume of solute divided by the mass of the or volume of the solution multiplied by 10 raised power 12 trillion. So a very small concentration of the solute can be calculated in a solution in the analytical procedures. These are very accurate. We just calculate the pollutants, how much pollutions are there in the atmosphere or any other sample. So you have to calculate these one. Dear students, there is a self-check exercise. Please calculate. This is the homework for you. Then inshallah, next topic after this, molarity percentage, molarity, mole fraction, parts per million, parts per billion and trillion. Then we will go directly towards the Rod's law, article 10.3. So thank you very much. We stop here. Inshallah we continue.